a dot and you could remember the letters that make up a dot. Nowadays you have these funny cartoons done with dots and specific characters, right? So this is exactly like this, but only thing is you build it up layer by layer into a model. So when you talk about 3D printing, the reason is because once you visualize something, you want a prototype to build. And if you look at the earliest models of, let's say we don't talk about this, first find the need for this and then go on to what 3D printing is. So those of you who are from an engineering background, you would know if you want to duplicate a part, what you would do is you make a cast of it. First you put it in a box, you put a clay around it, you make a mold, and then you pour molten cast iron or something to duplicate the part. Alright, that is fine. I mean, there are problems with that. It's not a smooth finish and everything. So what they did was they went into laser cutting. So you have lasers that can cut, so rotor blades and everything are cut to precision depending upon what exact dimensions are, very fine tolerances. So 3D printing is more on the reverse, it's bottom up. Instead of having to cut something, what you do is you build it layer by layer. This is, by the way, the tip there is known as an extrusion tip that will basically melt the filament and deposit it depending upon
what is the name of that nozzle?
It's just called a nozzle.
Just a
it's
nozzle.
just a nozzle. I'm going to go into the detail of it. So basically what it is printing there is from our printer that was printing a nut and a bolt. So you can see both of them there. And it prints layer by layer. One of them is, so you have these two printed separately and they'll fit exactly in like this, okay? So what it does is, I'm just gonna pass these around for you to take a look at the kinds. And before we go there, let me move on so that I can give you the, okay. So 3D printing is additive manufacturing. So additive versus subtractive manufacturing are two different things. Additive manufacturing is when you add layer by layer and you construct a piece. This is an example of additive manufacturing. What is subtractive manufacturing is, let's say I have a block and I cut it, right, to a specific dimension. So let's say I have a wooden block and I want to make some artifact. Let's say this was a piece of wood and I wanted to shape it into this, so I would remove, scrape it layer by layer. That is subtractive manufacturing. Additive manufacturing is if I go layer by layer. If you look at it, you'll see so many layers. This is a very crude print because we had just got the printer and we were not exactly sure of what settings to use, so we went by this. But if you look at the bottom, it's really smooth, so almost as smooth as the tail lights of a car.
You print out this one using that?
No, this is the large printer.
The large one.
It can be done, but we did it using the other one. So if you pass that around, and
You
even
can
this
put
one.
inside.
Exactly, I put a lot of things inside. This is a chest piece, and this chain, after we printed this, most people ask if this was put together, but it actually prints as a chain. So this is how it is. This has not been completely disconnected, so you can look at it also. And so right now, it's a very evolving technology. Right now, most 3D printers use plastic and resins, and there are few printers that also use metal. We have, instead of when you use metal, the biggest problem is that there's a lot of fumes and gases that are really not desirable. So
There's one printer, 3D printer with a chocolate. Really? There it is.
yes,
Chocolate.
chocolate.
Yeah.
Chocolate, yes. So this is the evolution of 3D printing. First in 1994 we had what was known as stereolithography. What is stereolithography? It's basically curing of resin based on ultraviolet laser. So you had an ultraviolet laser that would be actually pointed at parts where you wanted to solidify the resin, and the model would be slowly built based on that. So stereolithography was first introduced in 94, and then Stratasys, the company that owns MakerBot, last year Stratasys bought over MakerBot, and even though it's run as a separate brand, but in the near future it will be under the Stratasys umbrella. So Stratasys patented the FDM, which is fused deposition manufacturing. So fused deposition is, this is the filament that goes into the extruder. So this is basically the extruder, and you can see that this tip will melt out the filament that is going through it. You have the filament in here. So the filament is actually mounted in a spool right here, and it is pushed. You have two miniature motors that will push the filament, and the nozzle is heated to close to 180 degrees. Okay, so anything you do, make sure you don't touch the nozzle when it's on, okay? Because you'll burn yourself. That is one of the things. And even though it's actually accumulating, sometimes you'll find that it's accumulating a lot of material around the nozzle and you feel the temptation to actually touch and remove it. Please don't do that. So this is the filament, and so fuse deposition is basically melting the filament and depositing it layer by layer. Okay. So, and after that, people try to print a lot of material. The ultimate goal was to have, instead of, in case of there is such a big need of organs such as kidneys and hearts, and you have to wait for years for an organ donor for your right match. So if you can take the cells from that person and try to print the organ that he needs, that would be the best case scenario. So people have tried that with animal kidneys, and if you can see, the latest, somebody had a fractured skull, so her skull was replaced using a 3D scan model. Nowadays what they do, the most common use, I mean these are rare examples, but the most common use of 3D modeling and printing is if you have lost a tooth, it's really hard to find the one that feels normal. I mean, the first time you have a filling or something, it really feels abnormal, your tongue keeps going there all the time. So if you have the broken tooth, they can scan and actually make an exact replica of that so that it feels as a natural fill. And again, there are different examples. And RepRap is a forum, I would like you to check it out. RepRap is, the philosophy of RepRap is that they want the 3D printing technology to be completely open source. So the other large printer that we have is completely an open source model. You can download all the code from GitHub and everything. RepRap, the ultimate philosophy of RepRap is to have a 3D printer that can print itself. So a machine that can manufacture itself. That is the ultimate philosophy. The printer that we have, the 3DP large printer, almost 30% of its components are printed on the same machine. So right now we are having, I mean, technology-wise, there is a big difficulty in printing electronic circuit boards. So where you have the conducting part and the non-conducting part and everything.
But you can print out the house using the...
Well, it depends on how sturdy it is. But here's an example. Last year, some of you might have come across, those of you who follow technology news, that there was a completely functional car that was completely, totally, each and every part, 100% 3D printed. Okay? All right, so this is, looks cool, but I don't know how it drives, but anyways. So, and there are other examples. So the idea is if you can build it, actually not draw it, if you can model it in 3D, you should be able to build it or make it.
Also, you can find many samples for 3D gun.
Yes, there is a free website called Thingiverse where you can download the files that you want to print. It's an open source forum, you can just directly download it. So FFM is nothing but fused filament fabrication. That means you actually fuse the filament and it goes through the extruder and then you deposit by layer. So the bottom layer usually sticks to the plate. This is the base plate. Okay, this is a base plate. Usually it's made of glass, but or a plastic PLA, some kind of a plexiglass here. This is a masking tape so that the plastic can be easily removed. Okay, so the first two layers that you always print is known as a raft. So this one is basically a raft. Those of you who have taken a look at the chain, you will see the chain has not been completely dismounted. There is a small, like a layer between. So here you can see one of the layers is like this, the other layer comes across like this. So this raft will actually hold on to the masking tape, and then you will build a model on this. Okay. So what happens is, due to temperature differences, if this layer does not hold on to the masking tape, if there are huge temperature differences, the plastic will warp. And that's one of the problems when you print big models, it will start lifting up from one of the sides if there is a big temperature difference. So there are two ways to make sure that your model is very well printed. First thing is to make sure the extruder extrudes uniformly. So what it does is MakerBot always, whenever you give it an command to print, it will just print a straight line here to show you that the extrusion is working fine. Okay, it will print a straight line here. Then some people, usually I try to do that, is to try to build a small skirting around the model so to know that it's working fine. And a raft is absolutely essential, and basically you can scrape it off. So when you remove the...
So intentionally you put the first layer,
First
the
two layers.
line, the
Exactly.
straight line or the boundary.
Yes,
Okay.
exactly. We do that intentionally so
Even though
that.
you do not understand right now, the once you test it, you may realize.
Yeah, please, if you have any questions, feel free to stop me. And here's the other printer that we have has two extruders. So one extruder uses the red material, the other one uses white. So this is a double layered one.
So you
can
need to
print-
change the filament.
No, we have double extruders.
Ah, double extruder.
So
I
it will
see.
print at the same time.
Which one has that?
The
big
larger one.
Oh, okay.
The larger one has that. And the reason for having a dual extrusion is, well, there is another reason to have a dual extrusion. For example, I'm building this ground up, right? So it goes layer by layer like this. Sometimes what happens is, let's say I invert the model and I want to print it like this, right? It will print up till here, but when it tries to print this rate, it will just fall off, right? Because there is nothing to support it. Okay, so you have to be careful how you align your model, right? So that there are no sharp angles. And this is why you need a second extruder, because what it will do is, if you have a second extruder, it will build a support material, it will build small columns around it, so that it knows that when it comes to this point, the rest of the model will rest on that support, okay? And that support can either be removed, or depending upon what kind of a material it is, sometimes it is soluble, so you just dissolve it into something and all the support material will come off, and you can take the clean model out. Okay, so that is the real reason of having multiple extruders. You can have a support material loaded into one of them, and the other one will be the real build material. Or what you can do is have this as a single extruder with some kind of a thin support that you can break off, and you can do that. Another thing that is important is, if you look at this, if I try to build this model in a completely solid fashion, it'll use a lot of plastic because everything is solid. But what this is it's 80% hollow. Okay, only the outside two layers are too tight so that it looks smooth enough. So it's known as infill. How much of the percentage inside you want to be really solid or really plastic. So we go with 20% infill, depending upon your application, how much infill you want. So you don't want to waste a lot of plastic, so what you can do, this is a dummy piece, but we'll just build the outside two layers, tight or compact, and you can actually see that inside it's completely hollow. So here's an example of what the extruder looks from the inside. You have the spool of material, and that's driven by two motors. As the filament comes through the nozzle, it will be heated up, depending upon what material you're using, PLA, ABS, or whatever it is, and it will be deposited in an XYZ, wherever location the printer's STL file tells it to. So you have taken a look at the vase that we built. So this is an example of that. Layer by layer, it's building it up. In this case, you can see there are smooth angles, so it will build up without support. But if the angles are really sharp, then you will need some support material. So if you look at how to build and print step by step, the first thing is you need a CAD file or a CAD drawing, a computer drawing of the model that you want to print. And we use from CAD, we convert it into an STL language, which is the standard, I really can't pronounce this, tessellation language, STL. And this is what is used by most printers, and it's accepted. The printer will convert it into a file that it's basically a set of commands for the extruder to position itself in X, Y, and Z. It's known as a G code. So the STL file will be converted to a G code, and it will be given to the actuators, which is basically, this is a three-dimensional manipulator. You have X, Y control and a Z control. This base plate will move up and down. In the other printer, the extruder actually moves up and down. So then we move on to, basically, the software comes free, so you don't have to worry about it. I'm assuming you guys have an STL file, or I don't know how you are converting it to STL.
No. So if you are using R programming, there is a package to convert output into the STL file, so you can use that. But those who are using the Java or whatever, I'm not sure. But there might be the open source to convert such a, so you need to, that's your job to find, or I don't think you can manually create the STL file right now. It may take a time. So why don't you try to find the third-party software or object file or the package that can convert to your output. Your output probably the XYZ, value, or sometimes there is a graph. So why don't you try to make the try to find such a software.
Okay, so once you have the STL file, basically you can either load it through a computer or through a USB drive. There is a USB drive option in this case. And next thing is when you get to the machine, the first thing we do usually is to load the filament. So you can load and unload the filament. In this case, it's already loaded. But the beauty of this, the reason we bought this is because this display will give you a step-by-step instruction on what to do. So it's not like the other machine where you don't see any feedback from the machine. It'll tell you if something is wrong, you can read off it and do. So there are really two buttons to go back and this one to select. So you can press on it and go forward whenever you think that's the right option. We begin usually by leveling the plate. If the plate is not leveled, that's called the calibration. It will calibrate, the extruder will come down, it will touch 4 or 5 points on the plate to make sure that it's perfectly level. If not, you will see that there are 2 screws here that can be moved up and down to do it. And finally, once the build is started, it will take its own good time and you'll see the progress. This will give you the progress, how much percent it's over. I wish it starts up earlier. I can actually demo something. And then after it's over, let it cool down because when it's hot, you don't want to touch it. And once it's cooled down, then you can use a scraper. We have scrapers to take that off, but make sure that you don't pull off the model while the plate is in the machine. You have to take the plate out and then take the piece that you have printed. So I think in this case you don't need most of post-processing. The only post-processing probably would be to take in this case you have the bottom 2 layers, the raft as I spoke of, to take off. That's pretty much it. And there is no other. This is an example of a raft. And this is actually, so when you print, it's good to print with natural materials. Natural materials, this one does not have color. This is actually a colored filament. Colored filament has a problem because it's an added color, it's not natural color. But if you use a natural filament, the print should be smooth. And
Can we use multiple colors of the same object?
yes, you can. I actually gave a piece that was red and white. So you had dual extruders, right? So you can actually print with one extruder. If there was a second extruder, it'll use the other filament to print.
But this one is a single.
It's single. This one is a single.
It depends on the machine. There's one machine.
The big one is single. The other one is also
It's double.
no.
Double. Okay. The way you can do it, the only other way you can probably do it using a single extruder is you cut the file there, let it print that much, replace the extruder and have it continue from there.
But I don't recommend.
Actually, that's, this one, for example, was colored after it was printed. So I would recommend you do that. If there's really something that you want to highlight in the model, probably you would like to do it with a natural material and just paint it off. So these are the 2 most commonly used plastic materials, the polystyrene, PLA, and the ABS plastic. ABS, we use polystyrene because it's eco-friendly material, and this one does not degenerate. So the larger machine we have, we just got a spool of ABS, and there's a printer in the ME department that uses ABS, but we stick to PLA. All of this that you have seen is PLA. And I think we have PLA, so you will be printing with PLA. PLA is actually, it melts at a lower temperature when compared to ABS. So, which is a good thing, but it's not as strong as ABS is. This is the large printer that we have. It's basically the largest printer available in the market. The build area is 1 meter by 1 meter in the XY directions.
How
and
much is
half
that?
a meter
How much is that?
in, well,
The price?
the price, it's as expensive as a car, it's 20,000.
20,000?
Yes. Yeah. So, well, we got it for much cheaper because educational discount and this and that, but it's actually the market value is much higher. So, it boasts of a resolution down to 70 microns, but usually it's somewhere between 70 and 30 depending upon what material you're using. And the positioning accuracy is in the range of 10 to 30 microns. So the extrusion can position itself in span of 10 to 70 microns. And this is the nozzle diameter. Nozzle diameter is how thick you can print. There is a 0.6 and there is a 0.4 nozzle. So we are currently using the 0.4 nozzle. This filament, you cannot change the filament, even though both of them are PLA. The thickness of the filament is really important. So in this printer, we use a 3 millimeter. The MakerBot uses 1.7 millimeter. So actually, when you go down, the name of the GA who will be helping you, his name is Ernest. He can actually show you some of the models he has printed. There's a township that I showed it to you. It's actually a very good model that he was printing last weekend. So if you get a chance, have a look at that while you're down there. This is the MakerBot. This is the MakerBot replicator. We also have the Mini. So as I said, it's smaller. The nozzle size is the same, but the filament is different. So you cannot actually use this filament. And we also have a Mini. So if you want to, we actually have two of the MakerBot replicators. It really depends upon what size your model is. If you think you can fit in this one. The only disadvantage of this is that it does not have a screen, so you cannot run it from the display. This one I can run it from the display right here. It will display all the options, and I don't need a computer. In this case, you really need a computer. And the cool thing about the MakerBots is they can be networked, and you can actually monitor the progress. There's a camera, inbuilt camera. You can monitor the progress via your iPhone. So if you're working somewhere, and these are desktop ones, like you have a desktop printer, it's trying to push it as a consumable or a commercial device, something like a printer. Okay, so this is the next generation. I think I intentionally wanted to have this. This is the stereo lithography. So you can see that it tries to build the model upside down and from a liquid. So it's actually curing it using ultraviolet lasers, and you can see it's trying to print a ball from a liquid. So there is a laser at the bottom that only cures the model depending upon what the CAD model is. Hopefully we can get one of these.
Is it in the market or is it just a prototype?
No, it is in the market.
It's in the market.
Is it much faster?
It is much faster. It is actually 50 to 100 times faster than these because they go layer by layer by layer. So this actually cures by laser, an ultraviolet laser, and only cures the area. So it cures layer by layer by layer as it's building up. So, and then there is what is known as 4D printing also. I mean, which is basically the model will change shape with time. And I don't know if that's the right use of the phrase, but anyway, it's something that is out there. So let me just show you briefly here before I conclude. Everything that you need to do is here. So as I said, once you start with
But this is this assume you have a STL file.
Exactly.
Okay, you should make your own STL file and bring the file in the flash drive, then plug in.
Okay, so well, everything that you see, you have a print option, filament option. So you go to the filament option only when you have to load or unload the filament. Okay, so
Also, I think that if you download the program, MakerBot program, you can actually test, visualize what will be output before you print out.
Exactly.
Okay.
And it'll once you convert, when you convert your drawing into an STL file and you load it there and you prepare to print, there's a pre-processing stage where it will tell you the time and how much material it's
Or
taking.
you can scale up, or if it's too big, then you can scale down, and you can adjust the size of your.
Right, you can print it depending.
Yeah.
You can change the orientation and print it.
You can do the very simple modification using that.
So let me just try to do something here so that it feels alive. This machine. Okay, let me just try to. So for example, right now it's trying to. Okay, we have to unload the filament. So it is going to heat it to 200 degrees so I can remove the filament and you can calibrate the base plate. So as I said, it's much easier when you can just follow the instructions on the display and you can do it.
So when you print out the output of your project, please do not ask him how to make the STL file. It's your job. Okay. Once you have the STL file, then you can ask get the help to print out that.
Yes.
Okay. So then the problem is how to make the STL file. The one solution is if we are using R programming has the package to convert your output into that. Otherwise, you need to find any the third-party program, or if you are using the, I think the well-known the graph tool like the Origin Port, probably provide such an option. But otherwise, you need to find. Also, worst case, if you cannot find any the solution or your output doesn't fit the 3D printer, you can intentionally make the, for example, you have the histogram, it's a 2D histogram, you can make the something thickness. The one layer like the Z layer is the same as the X, and Y, and intentionally make the X and Y, Z, the 3D. It's for your the practice and the experience, okay? So,
yeah. And I'm gonna send the contact coordinates to Professor Lee, and he's gonna email you. I think you guys are working in groups, so.
yeah, we have the 7 groups.
Yeah.
So, is there any team who are ready? Yeah, then you can. You have the STL file.
Yeah.
Which program are you using?
Uh-huh.
So you use the R. Then why don't you tomorrow contact you or
Yeah,
the GA?
Yes. Please, when you send him an email, CC me so I make sure he's there.
Yeah.
And there's
I do not know his information.
I'll give it to you.
So once I got his information, I will forward to everybody. Then you
Yes.
can directly contact to him at that time. CC to me and him.
Yeah, so
Okay.
that make
I
sure
will
that
give his information also. Then you can set up. It will take a time. Please have enough time. So we have the total 4 maximum at the same time, but these 2 are recommended. But the mini board is small, but you need to connect the computer. But these 2 are recommended. But in the peak time, there might be 4 at the same time. But I strongly suggest to set up the time as soon as possible, just in case you mess up. You need more time. Okay. Easily to print out this thing, I think the
20
couple of-
minutes.
20 minutes for this. The mini board definitely is a couple of hours when I test it. Okay, so please, you see the last one that I print out, that took almost 3 hours using the mini makeover. Okay, so this one is faster, but still takes some time. If you size wise, not too small, but not too big. It's up to you if you can. So just think about the reasonable size, okay? And also, just in case you cannot make any STL file from your output, at that time what's the name of the site? It's a
Thingiverse.
Yeah, Thingiverse is something like that. They already upload the STL file. They make by themselves and try to share. Like for example, some keychain or something, this kind of thing. So try to find the similar objects as your output. Like if your graph is like the mountainside, try to find. So try to find because anyway, this is for your experience. So at least you should print out anything. But the first priority is from your output, convert to your output into the 3D. The STL file, then print out. Okay, we have one team who are ready, but the other team try to. And any question?
Yeah, and once you have your file ready, please have him check it first. If there's anything that pops out to him, he'll let you know before you print, because don't assume that your first print is going to be the real print that you want. You might have to do more than one print. So just go over, don't assume that you just walk in there and you print it and it will be done. So send him the file, let him actually have a look at it, and then if there's anything, he'll get back to you.
Also, you can download the program. I think without printer you can install, then you can see it's a kind of 3D visualize. So I think that I showed the last time, I'm not sure. But you can install the program, you can see your STL file, what will be the expected output object. I think that this one is calibration, right?
Yes, it's a calibration. So you can see there are 2 nozzles, knobs here that you can turn to calibrate it. So make sure you calibrate it yourself so you know how to use them. So every print should be preceded by a calibration. So when you do it, first thing that you will do is unload the filament, calibrate the plate, and then load it back again, and then you can go ahead and you can print it. And there is a option where it says actually preheat the filament. So before you print, make sure that it's preheated. He'll actually walk you through this group by group, but as I said, have your file ready and email him. Make sure Professor and me, both of them are CC'd on it. And
Also, the first time when you are using the 3D printer, do not start with first the 2-layer is print out the, what's the name of this?
Raft.
Yeah, so you don't have to stop. Okay, first time I stopped because it doesn't look like the object, but this is just the basic.
Yes.
Okay.
Please make sure that you do a raft.
And
There's one that
based on I print out the 3 or 4 times, but based on my experience, sometimes the nozzle is stopped, so it doesn't print a couple of layer. Then it coming out. At that time, you need to stop. Otherwise, it cannot handle the missing part. It's actually the push down, so it will be messed up. So if once you realize it's something the nozzle stop and missing couple of layer, then you stop and do it again. Okay. Any question?
What's the max dimension of the output?
the max dimension, let me have a look here.
The biggest one is 1 meter by 1 meter.
I mean this one.
This one you can see some
9 inches, almost 10 inches by 7.8 by 5. So that's for the, in case you want to know what size your model will be, replicator is this, and the mini is right here.
Yeah, you can imagine the size of this.
That's the, as large as the blue color is.
But the bigger size of your object is, the longer time.
Yeah, that's true.
Yeah.
Can we use the 2 color?
Can you use the 2 color? I would recommend you use 1 color and color it. Okay. Because I mean, I have
First,
no
why
problem.
don't you do this way? If you are successful for 1 color, then try the multiple color later.
It's much easier to print with this natural one.
Yeah.
Not even
Also,
the
I
red
think
color.
that depending on the program, you need to specify the color. Even though you have the 2 extruder,
Yeah.
you need to in your STF file.
Which extruder, which part is
Yes.
printed by which extruder has to be specified.
Any other question? I think try. It's better try. So even though you are not ready, if you want to print out the simple thing you download, it's also okay. Okay. So but do not bother a lot. The I think the GA. He's not the GA. He's a voluntary work.
He's a
Yeah,
volunteer.
he's working voluntarily. So do not bother a lot. So but they may be very helpful for your project. Okay. No other question? Okay, thanks so much.
Thank you.
Thanks so much. So please send me the contact.
Yes,
Yeah.
I will email it to you tonight.
Can I keep the file of this?
You can.
Yeah. I will. Do you want a PPT file for this? The 3D? Then I will.
Do you need a help? No, Thursday.
So we are not going to set up the printer in MIG lab. Instead, the old printer are already set up in the down basement.
Yes.
Anyone who ever been the basement? So basement, we have a lot of the equipment, and the printer is
There's-
one of them.
There is only one way that you cannot get wrong. You have to go through the elevator or the stairs,
Yeah.
so it only goes there. So.
And also, you need to have someone who has the access the room. So that is the reason you need to email him and CC to me and Sarosh. Okay. Yeah. Thanks so much. Are you going to take out this
Yes,
one later?
I have to go for a meeting.
Okay.
Please pick it
Yeah,
up.
thank you.
I'll take it outside anyway.
So before we start today's lecture, so I'd like to first check because we do better continue the workshop next week. Then why don't you see the handout? This is a summary. And also, I think. Oh no, it's mine. There might be. So this is my plan. I already the email or the send a message and also handout. So there are both sides. The first page is for this one. So this is just a flyer, but also the plan for this. There are two main events. One is the presentation in this room. The next week, Wednesday, 12 to 1:30. The Professor Dictor is teaching a course in this room at that time, but he will the end before noon. So we can right away. So I already asked and he agreed. So if you are taking the course, his course, you can just stay. Otherwise, you can wait outside. And noon, 12 o'clock, we will start right away here. Okay. Then I have several students who have the class. Is there anyone who are taking a course? No? Except the Professor Dictor's course. So everybody okay, right? So hopefully I'd like to follow the disorder 1 through 7. So I'm going to apply the time very, very strictly. So each team will have the 10-minute presentation. Okay? And transition time, so it will be a couple of minutes. So total it will be the 90 minutes, hopefully. Okay? Any question regarding to the presentation? It's an oral presentation with the PPT file. Okay? Okay. It doesn't matter whether you guys have a take turn for the presenter, or the one can present, another one manage the PPT file, or any others. It's totally fine, but it should be practiced. Then at the same time, in the same day, we'd like to display, as I announced, we'd like to display our output. So mainly 3 output. One is the poster. Okay. So anyone who do not understand what is the 2x3, the poster, everybody knows. Okay. That is used in the faculty research day or the ASE conference. You can use the same format. Okay. So you need to submit when is the due date for the poster? April 23rd, Thursday, because I need to ask to the Omar to print out. Yes.
Professor, we have not yet come to our final conclusion, so we cannot actually add that output in the poster. We are not ready with the poster.
So for the poster, if you are not ready by the Thursday, you need to get my permission. So at least email me. Okay? Otherwise, I cannot. I want to send all the file together to because they are just helping us.
Yes.
Okay? They do not have any responsibility for this. They are just helping, including the Sarosh Patel. He just helping us. So I don't want to bother them. So if you are not ready by the Thursday, at least email me when you can complete. But otherwise, please send it, upload to the Canvas. Okay? The PPT file. Okay. Then that will be the display in the tech conference room 121 from 10 o'clock to the 3 o'clock. Okay. Then the video. So I asked you to record the video, so you can make the less than 5-minute video. So you can submit. I already email you. Either send a message. The Google Drive. So if you log in with, I click and add the drive. Then you can upload the file to the folder. Okay, so you can upload the file. Then I will download them and install the 1 computer per team. So we will set up the 7 computer in the conference room. Actually, the laptop. It's a brand new laptop. Then it will be used for the wireless network, not ours. So anyway, so that will be displayed continuously throughout the
Professor?
workshop. Yes.
The video would be like doing a presentation. in
Whatever.
front of the camera.
So anything that you capture, it doesn't have to be formal. Okay? Any meeting or discussion or the displaying, even including 3D printer, so anything. Okay? That is the kind of a different output of your project. That is usually a lot in the sociology and the other subject. Okay, it's a kind of group project or even art. But I try to use this output first time in the computer science project. So, but sometimes that will be very, very helpful to understand what's going on inside your project. Okay, because this is not a formal the workshop or the conference. And the last one is a 3D visualization. So after you print out, the video should be also Thursday. Okay, this is the same thing because we need to set up the computer with Omar's help, so department. So we should have the all file as soon as possible. But in case you cannot submit it, just email me. And when it will be possible, it doesn't have to be professional video. Okay, you can even use the video editor in the cell phone. It doesn't take a time. Okay, so if you guys have a time, so you can put the credit or ending or the very nice formatting. It doesn't matter. Okay, but each team has 3 or 4 members, 3 members usually. So one of the member may be in charge of one of the output. And 3D visualization, as I explained, you need to select one of them. I first try to get the first output. Okay. Then if you like that, if there is a time available time, you can try more. Okay. It's fun, and also not many people, even including me, will purchase the 3D printer right now. But this is the experience. Once you get used to, whenever you need, you can actually use the 3D printer. It's not only for that student, it's for everybody. But if you do not have any experience, no chance. So this is another way of the presenting. So reasonable size, not too small. So if you print out this small, so it doesn't look like good. So please try to make the reasonable size that can be visible. Okay, and that is actually today. The reason why I put that today is it's available from tomorrow. So once I got the contact, you guys can start to print out as soon as possible, because the main problem is taking of time. Really takes a time. If you are lucky, you can print out at once, but probably fail or there's something problem, unexpected problem. Try. So there are 2 maker board and 1 small. It takes a longer time, and also the big one, but that big one takes a longer time than the maker board, he said. So think about probably they will consult you. So then that is the 3. Then I'd like to set up this way. Can you understand? So this is the Tech 121 conference room. This is the entrance. Okay, this is another entrance, right? And we have the 3 tables, and this is the screen. So I'd like to set up the 1, 2, 3, 4 computer and 5, 6, 7. So each team will laptop. Okay, then lean against the poster behind the computer, and put the 3D output next to the computer. This will be displayed throughout the day. Then I asked the engineering, the faculty and PhD student, they can voluntarily combine then the judging grade. So judging sheet is very simple. So the other side will be consider the project, the grade also. So you can invite more PhD students if you want a better grade. Do not invite your bad friend. And also after the presentation 1:30, the GA will set up the refreshment. So we will have how many pizza? 15? I'm not sure whether 15 may be enough. This is not really big pizza. It's for 2 or 3 persons. So I think the 15 may be enough, and with the drink. So until 3 o'clock, we can enjoy the event. Any question? Yes?
For the videos, With all the computers right next to each other, like,
Yes.
won't the sound be really
Sound. Reasonable sound. We cannot adjust it, but we cannot actually separate.
Listen to one. These are all- it'll be-
Yeah, I thought that, but it will take almost 30 minutes to display everything. So this is what I'm thinking. So those who are interested, they can volume or the
Headphone.
headphone. But I think that will be. Also, we do not have the kiosk style display. So this is small, so nobody. But if we display individual, they can actually in and out. They will not stay inside the room. So I think the volume, you can make the caption. Or believe the YouTube. I'm thinking after you submit it, I'd like to upload to my YouTube. Then if you speak very well, then automatically create the caption. But if you do not believe your speak, anyway, so volume. So if you wanna consider the sound, you can use the caption, or you can ask no. So I will put the name of the team 1, team 2, team 3, something like that. If you, so I strongly suggest to come by in the morning before 10 o'clock and check your group. Okay. Any other question? Yes.
Yeah, regarding the 3D printing, how can we contact him? Just
He will email me about the contact of the student. Actually, he's from mechanical engineering. Is there anyone who knows the? He's not actually GA. He is working for the department. Then he will have. So once I got his information, I will forward to you guys. Then you guys can directly contact him. But at that time, CC to me and Saroshi Patel. Okay. And also, optionally, you can submit the writing up after the event. You can submit the writing up as well as a source code that can be considered your part of the output, right? Okay. Then those who have the good result and the good method, you can try. So the conference paper, or if you want, you can try the further opportunity. Yes.
Our presentation will be on 29th April from 12 to 1:30 and
Yeah, 12 to 1:30.
and poster presentation also be
Oh, you don't have to present the poster. Poster it will be displayed. But oral presentation only in this room. Using the separate. The PPT file is the presentation PPT file. Okay, not poster PPT file.
So we don't have to explain what we research.
Where? In the room? If we want to, you guys can stay. It's up to you. Because not all students are available because you have class. But after this one, we can move to there so you can explain to others. Not like the faculty research day or ASC. You don't have to stay there. No other question? I think that so far so good, but the more important thing is the idea. Okay, definitely you should be able to address the problem and good understanding of the algorithm. But nowadays, the more important thing is the idea, how to present your output, how to make the problem. So that's the reason I try to use the different approaches for that. Okay, so if you do not have any further question, what time is it? Let's have the 10-minute break from 7 o'clock. Ali, are you ready? Yeah. So we will start from the social media mining for influence and analysis, then followed by the recommendation. I'm not going to have a lecture for the behavior, okay, but you guys can understand by yourself. Then if we have a time, we will see a little bit about the visualization with the art that we missed. Okay? Yeah, so we have the 10-minute break.